Okay, children, our next topic is motion of charged particle in uniform electric field. Okay, so although this chapter is over, but now when we did static electrostatic, so there was no motion of the charge. Now here, if the charge is there and it is moving and there is a uniform electric field, so if this here is a charge which is already moving in this direction, and this is the direction of electric field. So here you see, if it is a positive charge, the force on it, you know that a force on charge is Q into E. Okay, so if it is a positive charge, the direction of electric field and force will be same. That means this direction. If it is a negative charge, it will be opposite. Okay, now because I've taken just charge Q, so if it is positive, it is experiencing force in this direction. So what will be acceleration? Acceleration is F by m. So QE by m. Okay, and the direction of acceleration is same as that of the electric field for a positive charge. Now if suppose this particle moves from here to here, then what is the distance traveled by it? For that you can use S is equal to U, you can use formula S is equal to ut plus half at square, or at square, or all the three equations of motion can be used using this formula for acceleration. Okay, so the motion of this particle will be straight line motion only, because the force and motion was in same direction, so it will keep on moving in the straight line with the acceleration, that means with increase in the speed of the particle. But if it is a negative charge, then the acceleration will be in this direction, opposite to the motion. Okay, that means that will be deceleration, so the speed of the particle will decrease, it will become 0, and then finally it will increase in this direction. Okay, now if suppose the particle is not moving in the direction of the electric field but perpendicular to electric field, this is the direction of electric field, charged particle is moving in this direction, and the field starts from here to here. Okay, if the field starts from here to here, let this be x-axis. So the displacement in this electric field region, this is the distance traveled. What will happen when it comes out here? This electric field region ends here. So when it comes out, will it come out from here? No, it will not come out from here. Why? Because again the force acting on the charged particle will be QE, which is in this direction now. If it is a positive charge, in this direction. For negative charge, this is the direction. So there is a force acting in this direction, motion was in this direction. So initially your particle, was moving completely in this direction. There was no, so your initial, initial motion along x-axis was V, and initial motion along y-axis was 0. There was no initial motion. But acceleration along x-axis is 0. There is no force acting in this direction. But acceleration along y-axis is there. The force is, you see, QE. E is in this direction. So for positive charge, acceleration will be in this direction. So it is QE by m. Okay, this is along y-axis, up direction. Okay, so what will happen? Because of this acceleration, there will be a motion in this direction. It will accelerate, and although it will keep on moving straight, because there is no acceleration in this direction, it will keep on moving straight in this direction, but simultaneously it will move in this direction also. So instead of, so will it be a straight line this side? Let us see. So suppose after some time here x, this particle reaches y. Okay, this is the displacement along y-axis. That means sy. This is sy, or just y. Y is equal to ut. What is it? U yt plus half ay t square. Now how to find t? Time from here to here. So for that, x is equal to this displacement, sx is equal to uxt plus half ax t square. This time this part is there because ux is there, but this part will be 0. Okay, so you have vt because ux is v, x. So t is equal to x by v. This t you substitute here in this expression. Okay, this t you substitute. So what you'll get, y is equal to uy is 0 plus half ay is QE by m into t square. T square will be x square by v square. Okay, so you see here, this is initial. Q is constant, E is constant, m is constant, v square is constant, whole constant, x square. So y is proportional to x square. It's a quadratic equation. So it will be a parabolic path. It's not a straight line path. It will be this kind of a parabolic path. Instead of going straight, it is parabolic path. And this is the displacement. Okay. So whenever a particle is moving perpendicular to the electric field, it follows a parabolic path. Okay. Now if suppose this is the direction of electric field, okay, uniform electric field, instead of charged particle entering this way or perpendicular, if charged particle enters with some angle theta, okay, V is there. So now what you will do, now we can resolve this into two components. here your, suppose this is your initial velocity, ux is equal to v cos theta and uy will be v sin theta. Okay, so we will have to, now there is no acceleration along x-axis. There is acceleration along x-axis because this particle, the electric field is in this direction, so there will be acceleration. If your electric field is in this direction, okay, so you just see in which direction. Here in this case, ax will be qe by m. Okay, and what will be ay? Ay, there is no electric field in this direction, so there is no force in that direction. Okay, so the particle will move with uniform velocity u v sin theta. With this velocity it will move in this direction, and with this acceleration and this velocity it will move this direction. So here along x-axis you will have parabolic path, and here you have straight path. The combination will be a parabolic path. Okay, so then we can use all the three equations of motion. Sx is equal to uxt plus half axt square. Depending on the situation, whatever is there, you can use all the three equations along x-axis and along y-axis separately.